Alright, to continue with equilibrium, let's do another problem. Alright, so phosphorus pentachloride decomposes to phosphorus trichloride and chlorine gas. A 1.10 mole per liter sample of PCl5 was placed into a vessel. At equilibrium, it was determined that the concentration was 0.33 moles per liter. Calculate the KEQ for this reaction. So, from this, we know the equation PCl5 yields PCl3 plus Cl2. We also are told up here that initially we had 1.10 molar m of PCl5, but it also tells us that equilibrium, the PCl5 was 0.33. So we know all of this to start with. We know the equation, and we know PCl5 initial and PCl5 at equilibrium. They want us to find the KEQ. So to do this, we have to use the icebox. So when you set up your icebox, you have 1.10 under PCl5, and then there's nothing for PCl3 or Cl2 because they're products. And then for C, there's no coefficients in front of any of them. So on the reactant side, it's just negative X. And for each of the products, it's just plus X, because there's no coefficients to mess up with the numbers. And then you also know this bottom one down here for the equilibrium for PCl5 is 0.33 because it gave it to you in the problem. So to find X, you would take and you would do 1.10 minus X equals 0.33. So then you would switch the X to the other side and subtract 0.33, and you end up getting X equals 0.77. So then you just plug those back into your icebox. So now you have all of the equilibriums for each of the parts of your problem. So then you know that the KEQ equals the concentration of PCl3 times the concentration of Cl2 divided by the concentration of PCl5. So then you just plug in the numbers and you get KEQ equals 1.8. And you don't have any, you have naked numbers on this because KEQ doesn't have any number or letters or things to go on the back of it. Alright, so next problem we have at 100 Kelvin, the reaction below has an equilibrium constant KEQ value of 2.2 times 10 to the negative 10th power. If 1.00 moles of CoCl2 is placed in a 10-liter flask, calculate the concentration of CO2 at equilibrium. So from the problem, we know, here's the reaction, they gave that to you in the problem, but we also know the concentration of CoCl2 initially was 0.100 m because you have to do moles divided by liters, so 1 divided by 10, which is 0.1. And you just add the zeros for sig figs. And you also know KEQ is the concentration of CO times the concentration of Cl2 is divided by the concentration of CoCl2 equals 2.2 times 10 to the negative 10th power. So then you have to come over and do your icebox. So you have 0.1 for this because you know that, and then you know this part, the x's, because there are no coefficients to put any numbers in front of the x's. So then you don't have any other numbers. So basically you just do this minus this equals this. So you know that, and then since those are just all x's, so then you have to do a little bit of algebra. So then you come over and you plug those into the KEQ. So you have x times x, or x squared, just to make it simpler, divided by 0.1 minus x. However, because of the b to the negative 10th power, you know that this x right here isn't going to matter. So you could basically just like totally erase it from the problem. So then you plug in your KEQ value, 2.2 times 10 to the negative 10th, equals x squared divided by 0.1. So then when you multiply by 0.1 on both sides, and you get x squared equals 2.2 times 10 to the negative 11th power. And then you just take the square root, and you end up getting x equals 4.7 times 10 to the negative 6th power. So there's your x value. So then the problem asked you for the concentration of CO at equilibrium. So to get that, you just come back over to your icebox and you plug it in. So the concentration of CO at equilibrium equals x, and x is 4.7 times 10 to the negative 6th. But don't forget to add the m to the end, because you are now have to have, because you're not solving for KEQ anymore, you have to have attachments to your numbers. So that's it for equilibrium.